Okay, this video is about series circuits. So I've drawn a series circuit here. There's a 9-volt battery, and we have 3 resistors. They're all in the same line. We can see that the current would go from the positive terminal around through all of the resistors and then go back. There's only one option for the current. So for these circuits, oftentimes what we'll need to find is the total resistance, and we'll need to find the current. And for series circuits, there are voltage drops. And so there's a voltage drop for each of the resistors. Could also be a light bulb. So we want to find all 3 of those. So let's start with the total resistance. So our total, also called equivalent resistance, is the sum of all the resistors, right? So that sigma is to sum up. So for this problem, we have to add up R1 plus R2 plus R3. And so we'll just write out our total is 2 ohms plus 3 ohms plus 1 ohm. So the total resistance in this circuit we can see is 6 ohms. If we want to find the current, and for a series circuit the current is everywhere, we just use Ohm's law, I equals V over R. And we'll use the total resistance to find the current that's in this circuit. So we have a 9-volt battery, and we just found the total resistance is 6 ohms. And so this gives us 1.5 amps of current. So the next thing that we should do is we should find the voltage drops for each of the resistors. So if we look at the first one, R1, again we'll use Ohm's law. We'll solve it for V this time, so V equals IR. And I'm going to use the resistor 1. The current is the same, so we can just leave that as I. So V1 equals, we've got 1.5 amps. Multiply that by our 2 ohms, and we can see that our voltage drop across the first resistor is 3 volts. And then we just repeat this for the other 2 resistors. V equals IR. This is for the second resistor. 1.5 amps. The current is always the same everywhere in a series circuit. And we see this is 4.5 volts. And we'll repeat this one more time for the last resistor. V equals IR. So V3 is 1.5 amps times our 1 ohm resistor, and we get 1.5 volts. The way that you can check this to make sure that you've done it right is if you add up all the voltage drops, we should get the battery's voltage. So if I add 3 plus 4.5 plus 1.5, in fact I get my 9 volts, so that checks. So that's how we do our series circuit. Just remember to use the rules for series circuits and you should be fine. We'll talk about parallel circuits in another video. See you in class.